Okay, let's get into it. Our mission today is a deep dive into the physical backbone of professional live broadcasting. We're talking about how engineers solve that logistical nightmare of moving tons of high-bandwidth video and data, at the same time over huge distances. And we're going to focus on one piece of hardware that's a serious shortcut for this: the Thor Broadcast F-4SDI-3G-GET-TxRx kit. It's a bit of a mouthful, so let's just call it the F4 kit for now.
Right. And what's so fascinating here is the sheer consolidation it pulls off. The central challenge in any remote production is the heavy haul. How do you get, say, 4 unique high-definition video streams back to the studio? And not just the video, but a full bi-directional network connection, too. This kit's answer is put all of it over one single strand of optical fiber.
Just one.
Just one. So you're moving 4 physically separate 3G SDI video signals, and at the same time, you've got this Gigabit Ethernet connection. It's all happening simultaneously.
Let's put that in context. Think about covering a huge outdoor event. Normally, that would mean 4 heavy, clunky video cables, plus a whole separate network run for things like camera control. With this, you have your camera sending live 3G SDI footage back to the truck while, say, a networked PC is getting data, and it's all flying down the exact same super light optical link.
The logistical payoff is it's simplification. That's it. You only need a single strand of single-mode fiber. It's lighter, it's cheaper, and it's so much easier to run. And depending on the model you get, this system can push those signals up to 120 kilometers.
Okay, but if you're pushing video that far, signal integrity is everything. I mean, it has to be perfect when it arrives, right?
Yeah.
What are the technical guardrails here?
That's the key question. They engineered it with sophisticated input equalization and reclocking.
Okay.
Essentially, it cleans up and rebuilds the signal. Any little bit of jitter or degradation from that long journey gets stripped out, so what you get at the other end is a clean, stable picture.
And it keeps all the embedded data, like audio and timecode.
Oh, absolutely. It seamlessly passes all the SDI embedded audio and any ancillary data right along with the video. You lose nothing.
Now, let's pivot to the networking, because this is where I think the major technical takeaway is. It says the Ethernet port is an unmanaged pass-through transceiver.
Yes.
To me, that sounds almost too simple. If it's unmanaged and doesn't even have an IP address, doesn't that create other problems?
You'd think so, but its simplicity is actually its biggest strength for this kind of work. It completely avoids configuration headaches. It's not a switch or a router. It literally just acts like a very, very long Ethernet cable made of fiber.
So it's true plug and play.
It's the definition of it. You plug your router in one end, your device in the other, and they talk as if they were right next to each other. No firewalls, no subnets, none of that stuff you waste hours on in the field.
Right. It maximizes speed and minimizes human error when you're under pressure.
Exactly. And for the crew, the unit has these little real-time LED indicators. You can see your signal status, your optical link, your Ethernet connection, all at a glance. Plus, it's built using standard CWDM channels, so it plays nicely with other broadcast gear you might already have.
So for anyone listening who's thinking about this kind of infrastructure upgrade, what kind of investment are we talking about?
Well, it seems pretty accessible. The list price was about $4,500, but it's currently listed closer to $3,500. That includes free shipping in the U.S. and a 2-year warranty. And it's TAA compliant, which is important for government or university buyers.
And as a final thought for you, the base kit handles 4 channels. But this system can actually be customized for bidirectional transport. You could handle up to 16 total channels of signals flowing both ways over that same single fiber. The capacity is just astonishing.
So here's something to think about. Given that this hardware can so efficiently stack 4 professional video feeds in a full network onto one tiny strand of fiber, how does that push the absolute limit of where we can do temporary, high-quality live production? Where can we go now that we couldn't before? It really changes the game for what's possible in remote broadcasting.